Welcome back to the final project of this course. And in this one, we take everything that we learned throughout the course and put it all into one beautiful, modern, and really advanced application. So we're going to use things like classes, modules, promises, async await, parcel, and so much more. Also, we're going to dive even deeper into flowcharts and project architecture in this project so that you become more and more confident and prepared to actually write applications by yourself. So this will be a ton of work, but also a lot of fun. And so I can't wait to finally show you this project now. Hello and welcome to the biggest and most complete project of the course. And this is kind of the final project of this course, which brings everything that we have learned up until this point into one big and beautiful project. And so just like with the MapD project before, let's actually start by taking a look at this project. And this is it. So this is the Forkify application that we will build together over the next couple of hours. So this application is all about searching for recipes and displaying them here in our user interface. And in order to get a good idea of how this application actually works, you should probably follow along this demonstration by going to this URL. So Forkify v2.netlify.app. And so let's start for pizza here. And so you see that right away here on this left sidebar, we get all of these results. And when we have more than 10 results, they actually get divided up on multiple pages. So we have this nice pagination here, which is a very common feature of web applications, right? So you've seen this all the time probably. And so now in this project, you will learn how to implement this yourself. Now, okay. And now let's actually click on one of these recipes, and you see that then it shows up here on the right side. So we have the cooking time, the servings, all the ingredients, and then also a link to the page where the recipe actually comes from. Now here in the servings, we can actually decrease or also increase the number of servings. And as you see down here, the ingredients will then automatically get updated. Right? Then another cool thing that we can do is to bookmark recipes. So as we click here, then that button changes, and we also got that recipe bookmark here in this nice panel now. And here you see I already had a bookmark before, and as we click that, it will then of course move to that one. Now if we click here again, then that will basically unbookmark the recipe. And so you see that now it's gone. And let's do the same here. And so now it's empty. And we get this kind of warning message instead. All right. Now finally, we can actually also add recipes. So just click on this button. And then here we can just fill in this form. Now in this demo version, that's actually not going to work because that would very quickly clutter this entire application here. Now, what's special about this recipe upload is that all the recipes that you upload yourself will only be visible for yourself. So here, for example, I have this JS pizza, which was done by me. And so therefore it has this icon here and also this icon here. So it means that it was the user itself. Now, when you open up this page and search for pizza, then this recipe here should probably also appear for yourself, but that's only because this version has like a fixed developer API key. And so each recipe is associated to a certain developer key. And we will see what that means by the end of this section when we actually implement this. All right. But I think that's actually it. So that's the whole functionality of the Forkify application, which seems pretty simple, but it will actually be a lot of work to implement all of this. And so hopefully it's going to be a great learning experience for you. And once again, I tried to design this application like as modern and beautiful as possible so that you end up with a real nice application in your portfolio in the end. Okay, but with all that being said, let's now actually go plan this application. So now that we know what the project looks like and also how it works, we need to go through the same planning steps that we did in the MapT project. Now in this case, we will actually leave the architecture for a bit later and only talk about the user stories, features, and also about the flowchart for now. And to start, remember that a user story is a description of the application's functionality from a user's perspective. So basically, when we write user stories, we need to put ourselves in the shoes of our users. Now, all the user stories put together will then provide a clear picture of how the whole application is going to work. And so based on these stories, we will then be able to implement all our application's features. All right, so let's say that we are now kind of the project manager for Forkify, and let's also pretend that we didn't see the final version of the project yet, because of course we have to write user stories usually before we implement the project, right? But in this case, since we're kind of doing it together here in this video, of course it's better when we already know what the application looks like. But in the real world, this is basically going to be your starting point. So for this project, the first user story could be, as a user, I want to search for recipes so that I can find new ideas for meals. And so you see, again, we are using the format of as a type of user, I want to, and then an action, so that, and then a benefit. So here the user wants to search for recipes so that they can find new ideas for meals. Then next up, the next user story is, as a user, I want to be able to update the number of servings so that I can cook a meal for different number of people. And that of course makes a lot of sense in any application of this kind. Then next, as a user, I want to bookmark recipes so that I can review them later. And again, this really makes sense in any kind of real-world application like this. Then, as a user, I want to be able to create my own recipes so that I can have all my recipes organized in the same application. And finally, as a user, I want to be able to see my bookmarks and my own recipes when I leave the application and come back later. And so this way I can close the application safely after cooking. All right, and once again, let's kind of pretend that we came up with all these user stories while kind of brainstorming for this application. And so now we can use all these user stories for our next step and come up with the features that we need in the application. So first, the user wants to search for recipes. And so therefore, our application should have a search functionality, which is basically an input field which will send requests to an API with the searched keywords. Then the application should of course display these results and also with pagination to make it more user-friendly in case that there are many results. And then of course the application needs to display the selected recipe with relevant data such as cooking time, servings, and ingredients. Now the next user story is pretty simple, so all we need is a functionality to change the servings. So basically updating all ingredients according to the current number of servings. Then in order to bookmark recipes, we simply need a functionality for that. So basically allowing users to bookmark the recipe and then display a list of all of them somewhere on the page. Then for the next user story, what we need is basically a feature that allows users to upload their own recipes, which should then automatically get bookmarked so that the user can easily find all of their own recipes. Now, what's important here is that each user can only see their own recipes, but not the recipes from other users. And we could go ahead and implement this in a very complex way, like, for example, creating user accounts, but we will keep it very simple and basically simply associate uploaded recipes to an API key. And again, we will see by the end of the section how that is going to work. Now, finally, we are going to need a feature that will store bookmark data in the browser using local storage. And that we already did before, and so this part is going to be fairly simple. Then to finish, whenever the page loads, we need to then read all the saved bookmarks and display them somewhere on the page. Great. And with this, we now know exactly what we need to implement. But now let's take this list of unstructured features and actually put it into a nice structured flowchart, which will allow us to plan how exactly the application is actually going to work. So we're going to start only with these first 3 features in order to keep it simple now and not overwhelm you right from the start. So we're going to build this flowchart in 3 parts, and now starting with these 3 features. And as always, we're going to focus on events, and the first event in our web application should probably be the user searching for a recipe. And so that's our feature number 1, basically. So when a user searches for a certain recipe, then we need to asynchronously load the search results from our API. And so, of course, that happens asynchronously. And then once the results are in, we will simply render them in our application. However, we will not render all the search results right away because that would be overwhelming. And so instead, we also render some pagination buttons in order to hide basically part of the search results on different pages. So that makes sense, right? And then as the user clicks one of the pagination buttons, it will then render the search results for the new page that was selected, basically. And it will also render new pagination buttons. So for example, when we're on page 2, then there will be a button to go back to page 1 and a button to go to page 3. But when we're on page 3, then the button to go back will point to page 2 and the button to go forward will point to page 4. And so we need to re-render these buttons basically every time that the user clicks on one of them, right? Then finally, we also need the logic to actually display the recipe. So when the user selects a recipe, then we need to asynchronously load all the recipe data from the API, and then once the data arrived, we render the recipe to the user interface. And we will actually also do the same whenever the page loads with a recipe ID in the URL. So I think I showed you that in the beginning of this video. So whenever we click on a recipe, then the URL will change with the recipe ID. Remember that? And so it's important that, for example, if we take that URL and copy it and paste it, for example, to another browser, that then the recipe corresponding to that ID should also load right away. And so that's why here in this flowchart, I have the load recipe on both events. So when the user selects a recipe from the user interface, or also when the page loads with a recipe ID already in the URL. All right, and that's actually it for part 1 of the flowchart. And in fact, these are basically already our core features. So the most important features of the application. So searching for recipes, rendering search results, and then also rendering the individual recipe that was selected. And so all this will probably take us half of the section to implement. So there really is a lot to do. Now we will start implementing the project only with the recipe displaying. So only feature number 3, which is basically this right part of the flowchart. And this will allow us to start implementing some functionality and also play around with the application a little bit, but still without thinking about the architecture. and so without the rigid structure that might be imposed by the architecture. Great. So with this, we basically have this part of the application planned, and so let's now finally get to work. All right, so let's set up our project and also start to load some recipe data from the Forkify API. And here, as always, I already have the starter files loaded. Now this time we have a bit of a different structure here. So I have index.html out here, but then all the rest of our assets for this project are here in this source folder. So in the source, we have images, JavaScript, and Sass. So for JavaScript, right now we have controller.js, which contains this little starter code here. And then I have this Sass folder. And in case you don't know, Sass is basically a better way of writing CSS, which has some nice additional features, which makes writing CSS in a large-scale application a lot easier. Now, browsers actually don't understand Sass, and so it has to be converted to CSS. And so Parcel is going to do that for us. And so I left these Sass files here so that you can see that Parcel is actually also capable of doing that. All right, and then here, just some images. And of course, down here, we have our flowcharts and also a small diagram about the architecture. Okay, but now let's open up a new terminal here. And then just like before, we need to initialize a new project by writing npm init. And so this command will then create our package.json file. So this project should be called simply Forkify. Then the version might be version 1. Here let's just say recipe application, or really whatever you want. Then this one doesn't matter, neither this one. And now you can just add your own name here if you'd like. And so that's it. And so again, this now created this package.json file right here. Let's get rid of this one here actually. Or actually, let's just change it to .html. So this is kind of our entry point. So let's specify that here, even though it's not really important. And here I will start by setting up the npm scripts now. So just as we did in the last section. So this one is going to be npm start instead. And here we will want to start Parcel on index.html. So index.html is again going to be our entry point. And then since we are here, let's also already add our build script. So basically the command that we are going to run in the end once we're ready building the application. And again, index.html. Now sometimes in projects we don't even have an HTML, and so of course the entry point can also be a JavaScript file. And also this could be in a different folder, and we can specify all that here in the Parcel command. But once again, we are just keeping it very simple here. Now, in order to actually run Parcel, of course, we need to install it. Now, in the last section, we simply installed Parcel by writing npm install Parcel, and then as a dev dependency like this. And so this would then basically install simply the latest version that is available on npm for Parcel. And at the time I'm recording this, that is version 1 point something. However, Parcel 2 is almost ready at this point, and so I want to use a beta version of Parcel 2 so that you can use Parcel 2 in the future. All right. So if Parcel 2 was already out, then we would simply write @2 like this. However, right now it's just a beta version, and so I have to type @next and then add it as a dev dependency. So again, I'm writing @next here to install a beta version. So let me run this, and in case that you get any error, then please go ahead and simply install Parcel at 2. So you see here that this is going to install at 2.0.0 beta 1. Okay, and here we go. So again, you see that we are at version 2 beta 1. And if you got some error here, again, then please try Parcel at 2. So it's really important for the rest of this section that we are actually all on Parcel 2 dot something. So here it doesn't matter if you have 2.1 or 2 or 3, but it should be 2. So that's what matters from this part. And so now let's actually start Parcel by running our npm script, npm run start. And actually the start script is a special one in npm, for which one you don't even need the run. So you can just write npm start, and that will then call your start script. All right, so it's installing Sass, and now we get this error here for the module Sass. And so let's quit this here with Control C, and then I just say npm install, and so this will then install Sass here for us. But if you're still running into some kind of error with Sass here, then please just try to install Sass using the exact same version number. So npm install Sass and then at 1.26.10. And so that should then fix any remaining problem. And if it didn't, so if even after that you still run into some problems, either with Sass or with installing Parcel or running Parcel, then please take a look at the frequently asked questions in the GitHub repo. Okay? And only in the last case, you can of course also ask in the course Q&A section. But anyway, if we now try to run npm start again, then it will work. And indeed, here it is. So we now have the node modules folder, which contains, well, tons of modules. And then we also have our distribution folder, right? And you see that here everything is in one folder. So our index.html, and then also the controller script, which is this one. Well, not really this one, but the compiled one. And also you see that now we have an actual CSS file, and you also see all the images. So a real CSS file. Let's take a look at index as well. And so you see that now it replaced the controller.js here in the source. And also here I was referencing the SCSS file, so the Sass file. And it is because of this that Parcel actually knows that it needs to compile the Sass file to CSS. So basically I referenced this Sass file here, and therefore Parcel knew that it had to include that file in the distribution as well, and to also replace then the link to the actual final CSS file. And the same is true for all the images. So it basically copied all the images to the distribution folder and gave them a new name and replaced their source here in the HTML. Okay? And this is very important to keep in mind as we go building this project. But of course, this folder here is not really important for us in development. So everything we will develop will be here in the source folder, and only what we then see in the browser is actually coming from this distribution. So again, that's the whole logic of having a module bundler. So it takes our basically raw source code and compiles it into this nice package here, let's say. So this folder that is ready to ship to browsers. Okay? So for now, we no longer need this HTML file. And so we can now think about our controller here and actually think about making our first API call. And we can actually also open the page here by clicking Option and then here. Well, that opened in another tab for me. So let me just copy it right here. Okay, let's open up the developer tools as well. But for now, of course, we have nothing here because we don't have any code yet. But let's just log something to the console just to see that our parcel setup is working. And you see that it already built a new version. And indeed, we have test now in our console. Great. So everything is working. And so, yeah, let's now make our first API call. Now, for this project, I actually developed my own API so that we are not dependent on any third-party services. And the API is at this page. So let's copy it and let's go there to check out the documentation. So any good API needs some sort of documentation. And so this is the documentation that I wrote for our Forkify API version 2. So version 1 was for the old version of this course. So some details about this API is that search terms are limited. All you can search for is the terms that are in this list here. But to test this application, that should be enough. And you can only make 100 API requests per hour in order not to overload our servers. Because again, this is here my own API that I'm running on my own server. Then the API key is what we will need to upload our own recipes. But again, more about that later. And then here we have basically our main URLs or routes of this API. So the first one is used to get all the recipes or to create a recipe. But for now, let's focus on this one, which is simple to get one single recipe. So the path of this part of the API is this here. So this URL then /recipes/the ID of a recipe. And down here is an example of that. So for example, this one here might be the ID. And then here the key, but again, the key doesn't matter for now. And we can click on this and then see exactly the kind of result that we will get. And so actually, this is the URL that for now we will use in our code to basically get exactly this recipe here in our application. So let's copy this and go back to our code. And so now, as always, to make an AJAX request to an API, we use the fetch function. All right. And now that we have this, let's actually create some function around this. So an async function so that we can use async await. So let's call it show recipe. So an async function. And then here, as always, we use a try catch. And if there is an error, we want to alert that error. So very simple error handling for now. And now let's take this here and await it and store the result into the res variable, which stands for response. And I hope that all of this here is nothing new for you at this point after the last couple of sections, right? So just keep in mind that using the fetch function here will return a promise. And so since we are in an async function, we can then await that promise. So basically we will stop the code execution here at this point, but that's not a problem because this is an async function anyway, which only runs in the background. So we are not blocking our main thread of execution here. But anyway, once we have that result, we then need to convert that to JSON. So as always, let's create a data variable and then await the response.json. So the JSON method is, again, a method that is available on all the response objects. And a response object is exactly what the fetch function here returns. And so, yeah, we can then call JSON on that response, which returns another promise, which we then have to await again And in the end, we will then get our data stored to that variable. Okay. And then let's actually console.log both the response and also the data. So give it a save. And we also should call this here right at the beginning, because otherwise nothing is going to happen. And so, which one is ours? Here we are. Okay, and you see that we already have a result here. So first is the response. And so again, as I mentioned, this returns a response object. But then the data itself is here. And so we get this status here, and then the data itself. Make it a bit bigger here. Okay. And so then here, inside of data, we get the recipe itself. Okay. So it contains all of this data here, cooking time, the ID itself, then the ingredients, publisher, servings, and so on and so forth. So that works beautifully. And as always, we started here assuming that there will be success. But now let's try to create a wrong ID here, which doesn't exist on the server. So just something like this. And let's see what happens then. And so you see, we get the bad request. Here then in the response, we can see that OK is set to false. And so this is what we're going to use. Remember that? So when OK is set to false means that there was some kind of error in the fetch. And so we can then use that to create our own errors. So again, just like we learned in the asynchronous JavaScript section. Okay. But then we still get a response here. And this response says fail. And then also this message of invalid ID. And then the ID that we provided. So also the API itself returns a nice error message. And so let's actually use that error message now. Okay, because simply bad request is not a very informative error message. It's way better to actually use the one that the API returned to us. And so that's at dot message of this object. So we need to do that after this one here. And so we can say if response.ok is false, so basically if response is not OK, then we want to throw a new error. And then in there, we can use the .message property that I just mentioned. And again, that one is already coming from the data. So from the response of the server, while the OK property is stored in the response itself. Okay, and then let's also provide the status code. So that is at response.status. Okay, and you see that somehow we already get the error here, even though we're not at Chrome. But anyway, that alert window appeared, of course, because down here in the catch error, we are alerting exactly that error that we throw here in the try block, right? And so as we go here, let's just try to reload. And so indeed, here we get our error as an alert window. Okay. But now let's take it back actually. And so when we're back, then our data here is also back here. Okay. Now just to finish, let's actually format that data a little bit nicer. So basically I want to create a new object based on this object, which has some better variable names. So here we have, for example, these underscores, and these are very unusual in JavaScript. And so many times what we do is to basically kind of reformat this object that we get here. So basically I want to get rid of these underscores. And so let's create a new recipe variable, which should be data And then remember that it is again data and then dot recipe. So let's see that again just to make sure. So this here is the data variable, and then in there we have data again, and then in there is dot recipe, right? And so here we have recipes on both sides, and so we can use destructuring. So let's take that back. And I called this one a recipe with let, so that we can now basically create a new recipe object based on that. So the ID is recipe.id. The title is going to be recipe.title. The publisher will be recipe.publisher. And there would have been other ways of doing this, but this is kind of the quick and dirty way. So source URL is going to be recipe.source and then underscore URL. So this is one of the ones I wanted to change. Then there's also an image URL property, and this one I want to simply call image. Image URL. Then the servings might be just recipe.servings. And we're almost done here. So cooking time is recipe.cooking time with an underscore. And finally, ingredients is recipe.ingredients. Okay. Now let's actually get rid of this and simply log to the console the recipe object that we just created. And here, ingredients looks wrong. Ingredients like this, and here the same. Everything else looks correct. And yeah. So here is our nicely formatted recipe that we just got from the server. And of course, that would work for other recipes as well. So let's go back to our documentation page and get some other ID. And so that ID we can basically get from this search URL. So this path here will take us to all the recipes there are for a certain search query. So let's try this one here, which is for pizza. So you see, it is the route, so the URL that I just told you, /recipes. And then we have this query search set to pizza. So after this question mark. And this is a very common format of basically sending variables over URLs. So search is like a variable, and then pizza is that value. And so in this case, this is the query string. And in this case, what we want to search for is pizza. And so let's now just take any random ID of these. So just copying it. Let's go back here. And then I will just duplicate this line and comment it, and then replace this part here of the URL with this other ID. So you see it's slightly different, and so now we should get a different recipe. So let's see. And yeah, this time it is called pepperoni pizza burgers. And so of course, later in the real world, we will then get these different IDs from our search results here in the sidebar. Okay, so we successfully started up our project and already did our first API call to the Forkify API that I created just for this project. So this was a nice start of the project, and now in the next video we will then actually already render this data to the user interface in order to create something like this here. And I hope you're excited for that, and so let's quickly move on. So after loading the recipe data from our API, let's now render that data in our application. And for that, let's go to our HTML file to basically get the template from there. Let's close down this terminal, which will keep working in the background. And so here is the results part. the pagination, and then here we have the recipe class. So the recipe class is basically this whole container. So here in this case, it's this whole gray container, which is the one that will contain the rendered recipe. Okay, then right now it has that message. So again, it is this message here that is already rendered there at this point. Then here is the code for a loading spinner, for an error, and then here actually for the recipe itself. So here we have that image, and then all of the information about the recipe itself. And so it's all of this code that we need now. So let's grab all of this commented out code and copy it and paste it here into this function. So let's add a comment here. So loading recipe, and then afterwards, as step number 2, rendering the recipe. And for now here we are doing this like really big function. But of course, once we start thinking about the architecture, we will then break this up into functions and modules and classes and so on and so forth. And so, as always, doing a big template literal here, just as always, so that we can then replace all the data here that we need. Just fixing the indentation here now. And so now let's take all the data that we need. And the first one here is the image. So let's replace this string here with recipe.image. So just like we specified here. And so this image property is basically a URL which points to the location of the image on the Forkify API server. Then here we have the recipe title. So this one here. Dot title. And actually we also have that title here as an alt text of the image. Okay, then here we have the clock. So this 45 here is the cooking time. So recipe, and missing the block here, dot cooking time. Then down here we have servings, and so that's this number here. So number 4 will now be replaced with the data coming from the recipe object. So recipe.servings. And let's keep going. So down here we have the ingredients. So for each ingredient, there will be one list element of this. So in this example, right now we have 2 list elements and 1 for each ingredient. But let's actually keep that for later. And for now, keep filling the rest of the data here. So this is the next piece of data, which is the publisher. So here it says recipe publisher. And so let's change that to recipe.publisher. Then here we have the source URL. So let's take a look at that maybe here to make more sense of this. So we used most of this data here already. So here is the URL to the recipe itself, where it actually comes from. And then about the ingredients, as you see, it is one array, and each position of the array contains one object, which contains the quantity, the unit, and the description of each ingredient. And so we will have to basically loop over this array and then use all of this data to create one list element for each of them. Okay, but for now, let's go back and finish the data here. And in this case, replacing this URL by the one coming from the object. So that's recipe.source URL. And so except for the ingredients, that's actually it. So yeah, before we can check out the result, of course, now we need to actually insert this HTML into our DOM. So for that, we can use the insert adjacent HTML method. And we need to do that on the parent element, remember. And I already selected that up here. So remember, that's the element with the class of recipe. So just to remember, it is this div element. So that is called recipe container. And so that's where we want to attach this HTML markup. So recipe container dot insert adjacent HTML. Then let's do after begin. So basically as a first child, and then the markup variable that we just created. And that should be it. So this should now render the recipe in the user interface, except for the ingredients. And indeed, that's looking really nice already, right? So the ingredients are still the old ones, but the rest is really nice, except for that we have still this message here from the beginning, and also that we are missing all the icons. So you see, there are no icons to be found here. In the real one, of course, there are icons all over the place. So we have three problems here. We have this message showing, we have the ingredients, and we have the icons. And let's start with this message and then the ingredients. So before we insert any new markup, we need to get rid of the markup that is already there. So let's simply do recipe container dot inner HTML and set it to nothing. So emptying it out. And so you see, now it is gone. All right. So let's now worry about the ingredients. And again, we will need to loop over the ingredients array. And for each of them, we should then create this kind of markup here. So how should we do that? Well, basically exactly what I just said. So we take recipe dot ingredients, and then we loop over that using some array method. But what array method should we actually use? Well, remember that in the end, the expression that we need here needs to return a string of HTML. And so that means that our array method needs to return something. So for each is not the way to go here. So not for each, right? But instead, we are going to use map. So map returns a new array with the same length. And so that array we will then in the end be able to simply join. And so now we can loop over the array by specifying a callback function. So each element is going to be called ingredient. And then here we can do something. So let's simply replace a string here. Right? So taking this and put it right here. And then of course we don't need this one anymore. Okay. Then here we have some kind of error. But never mind. Let's think about the data here first. So let's take a look at the data actually again. So at the array, so each array element is an object which has quantity, unit, and description. Okay. So this ingredient is now that object. And so here we can say ingredient dot quantity, then here the unit, so ingredient dot unit, and then finally here, instead of pasta, we want the ingredient dot description. And so now here we will have an array in which each element will contain this markup corresponding to the ingredient. And so now all we need to do is to transform that array of strings into one big string. So we can take the result of this map which is that array, and call join on it like this. And so now the result of this entire expression is going to be a big string containing all the ingredients. So if we give it a save now, then indeed, here we have our 8 ingredients. Okay, so that's pepperoni pizza burgers. And now, remember we have a second one here, so let's switch them out again. Give it a save, and now we get, well, this pizza here. And so indeed, it now has different ingredients, different publisher, and everything is different. Great. But now there is one thing missing, which is the icons. So let's see why that is. Well, remember that the page that is displayed here in the browser is this HTML here from the dist folder, right? And so remember that all the images and really all the assets are now coming from this folder. And that includes the icons. So our icons are always coming from this icons.svg file. But now the icons are actually coming from icons.all of this here. And you can see that, for example, right here in the search bar. So icon search is coming from icons.96 and so on and so forth. However, in our template literal, we are still writing basically the old path to the icons. So this one here. And so right now, JavaScript will not be able to find this. So in the dist folder, this one here, there is no source / image folder in which there is icons.svg, because that exists only in our source folder. So only right here where we are developing the application. But again, right now, we are basically shipping the application already. And so it's using the data from this dist folder. And so now we need a way of telling our JavaScript that the icons file is no longer this one, but instead it is this one. And we can actually do that with Parcel by basically simply importing the icons file. So let's go to the top of our file, because I like to keep all the imports always at the top. And so again, in Parcel, we can import more than just JavaScript files. We can import all kinds of assets, and that includes images. So let's import, and let's call it simply icons, but this name can be anything that we want. From, and now the path to the original icons file, basically from the view of this controller file, right? So here we are in controller.js, and so now we need to find the path to the images. So to this original icons file. So we need to go one way up. So exactly the way we browse the file tree in the terminal. So ... always means the parent folder. And so right now we are back in the source folder, which is the parent of JS. And then from there, we can go into images and then icons.svg. All right. Now, this is the way it used to work in Parcel 1. So if for some reason you are running Parcel 1, then this is the way to go. But in Parcel 2, it works almost the same way. But then for any static assets that are not programming files, so for any like images or videos or sound files, we need to write URL, then colon, and then the path to the file. Okay, so let's take this out. And then let's log this icons to the console so that you see what this icons really is. Because in fact, it is nothing more than simply the path to the new icons file. So the localhost 1234 is in this case basically our dist folder. And then in there, the file that we need is icon.96f and so on and so forth. And so that is exactly this file here. Okay? And so now let's use that. So everywhere it says icon, So everywhere we have this old path, we now want to replace it simply with the icons. So let's select all of them using Command or Control D. Or if that doesn't work for you, you can always probably use Command F or something like that. But anyway, now we have all of them selected at the same time. And then I can delete them all and then insert the icons variable here everywhere. And so now, if we give this a save, then our icons are back, right? So starting here, then in all ingredients, and here also all over the place, we now have our icons back. And now just to finish this lecture, I want to give this one more touch, which is this here. So watch what happens here in the recipe when I load the page. Well, that was pretty fast. Let's see again. So maybe for half a second or so, you saw a loading spinner there. And so that's what I want to have here as well. So before the recipe arrives, I want like a loading spinner there, because that's a very common pattern that you see in all kinds of applications, right? And it's actually very simple. So we have the code already here in our HTML. So it is this spinner here. So let's grab this code, and then here I will simply create an external function called render a spinner. And let's make this a very generic function that we can reuse. And so let's pass in the parent element. And so then we can simply attach this to any parent element that is passed in here. So as always, creating a markup variable, and then our code here. And just like before, we need to now replace this old path with the new path. So icons. And then, of course, we need to add this HTML to the DOM as a child of the parent element in this case. So parent element dot insert adjacent HTML after begin and markup. Okay, and now let me just quickly show you why this is going to work. So here in the CSS, let's look for spinner. And here you see that the icon inside of the spinner class has this rotation animation that keeps going forever. So that's this infinite attribute here in the animation property. And this rotation animation I created here manually using keyframes. And basically what it does is to rotate the element to 360 degrees. And so if you ever need a spinner like this, you can simply basically copy this code here. All right. Let's close what we don't need here. And probably before we insert this, we should also clear the parent element. So just like before, setting the inner HTML to nothing. And now let's actually render the spinner. So let's do that here as we load the recipe. So right here. So render spinner, and then the parent element in this case is going to be the recipe container. All right, let's go back and reload. And there it was. You saw it. Let's make this a little bit slower by changing our network speed here. And so it took a little bit longer, maybe slow 3G is going to be even better. And so now it's going to take a lot more time. But indeed, here it is. So that spinner is a nice touch, I think, and it definitely makes this application feel more real world. Now, just to finish this video, something that I should have done in the last video already is to add polyfills for ES6 features to our code base. So just like we did in the previous section as well. So remember to do that. We installed some special packages. So the packages are called npm core.js, and we can actually install multiple packages at the same time. I think I never did this before. So this is how it works. Regenerator runtime, and then hit enter, and then let's wait for these packages to download. And here they are. So they should be, yeah, so right here. And now all we have to do is to import them here at the top of our file. And so with this, we make sure that most real old browsers are still being supported by our application. So actually we don't even need to save it anywhere. We can just say core.js and then stable. So VS Code, one more time, is really smart and can really help us with package imports like this. So again, this one here is for polyfilling async await, and this one here is for polyfilling everything else. And we could just cherry pick some features and only import those, but let's simply polyfill everything. Okay, don't need this terminal anymore. This one here already reloaded. And you see, everything keeps working the same. All right. So we have this working. Now in the next video, let's quickly add some event handlers so that after that, we can start talking about the architecture. Let's now add some event listeners to our application and kind of simulate that we already have some search results in place. And let's start by taking a quick look at our flowchart here. So we already implemented this part here of loading a recipe and also of rendering it. But now in this lecture, we want to also hook up these two event listeners here so that the recipe is actually loaded on one of these two events here. So when the user selects a recipe from the results list, or when the page loads with a certain recipe ID. Okay, so let's do that. And let's also take a quick look here at the demo version. So searching for pizza again. And let's click on any recipe here. And so again, here you see that we have this hash. So everything that comes after this hash symbol here is called the hash. So this is the ID of the recipe, and all of this together is called the hash. And the way this is going to work is that whenever this hash here changes, a new recipe is going to be loaded. So if we click here now, watch what happens there in the hash. So you see that it changed. And that changing of the hash is actually an event that we can listen for. So again, the hash here now changed, you see. And so we can then listen for that event, take the hash, and from there take the ID, and then load the recipe with that ID. Okay, did you follow that? And if not, that's not a big deal. So let's just see in code what I mean by that. And to start, we actually need a way of triggering a change of the hash. All right, and we can do that by adding a fake link here in the search results. So let's simply add a link here with the href of hash. And then here as the hash, let's actually copy this one. And you can copy any other ID. This doesn't really matter. This is just to show you how we can listen for the event of that hash changing. So give it a save. And so here now is that very small link. And watch what happens when I click here. So you see that the hash changed, right? And actually, let's add another one here. So 1 and 2. And now here from the controller, I can get one of these IDs. So let's say this one and put that one here. So these are two IDs of two different recipes. And now as we click each of them, you see that the hash up there in the URL bar keeps changing. And so again, we can listen for that event. And so let's do that now. So let's come down here. And then window.add event listener. And the name of the event is called hash change. Okay? And the function that we want to run then is show recipe. So let's remove it from here and only run the show recipe function whenever that hash changes. However, that is not really helpful yet, because the next step is that we actually need to get the recipe ID from the hash, right? So let's go up here. And so let me just show you what I mean. So right now, when we click here, then some recipe will get shown. So you see that it loaded this spicy chicken, but now if I click here, then it will load the same one, because we are still hard coding this ID here. But instead, here we want to show the recipe with this ID and here with this other ID, right? So we want to dynamically get the ID here from the hash. And that's pretty easy to do, actually. So we can actually do that out here of the try, or we can also do it inside. So that's not really important. So let's say the ID is window.location, which is basically the entire URL. And then from there, we can take the hash. Now that's not yet everything, but let me show you what the ID looks like right now. So let's see. And here it is. So it's basically the ID plus this hash symbol. And so we want to basically remove this first character. Or in other words, we only want to start reading from the string basically at the first position. So we can do that easily using the slice method starting at 1 all the way to the end. And so now, instead of having the ID hard-coded here, like we have right now, we can simply insert the ID right there. So, ID. And so let's now check. Okay. And now it's Jay's signature pizza crust. And if you go here, then it's the spicy chicken. And as we click here, then again it changes. And you see that the ID that we get here of this recipe object is indeed exactly this one here that is coming from the URL bar. Great. So this was actually already a pretty important part of our application's functionality. But now what happens if we take this entire URL and copy it and want to open it in another tab? Well, then no recipe at all shows up. And so that's because this time the hash did not really change, right? We simply opened this page here, but we never changed the hash. And so we also want to listen for the load event. So basically for the event of the entire page loading. Okay, and that's easy enough. So all we would have to do is duplicate this and listen for the load event. So this event here is fired off immediately after the page has completed loading. But here we have some duplicate code. And so I actually wanted to show you a nice way in which we can do all of this at the same time. And imagine you had like 10 events for which you wanted to run the same event handler function. So then it wouldn't be good to have this same code here 10 times, right? And so instead, what we can do is a nice array which contains these two events. So hash change and load. And then we can simply loop over this array and do something. And so for that, we use for each. And in this array, each element is an event. So E for event. And then here all we have to do is window.addEventListener, and then the event, let's call it EV, because usually the E is the actual event object. So let's not get confused here. So the event, and then the handler function. Okay, so this is now exactly the same as having these two lines here. So in the first iteration, this EV will be hash change, and in the second, it will be load. Right? Let's just comment this part out. And, well, let's copy this again, close it, and open. And indeed, now it loaded the recipe right at the beginning. Okay? And now just one more scenario. Let's say we didn't have any hash. Well, then we get an error, right? So something went wrong, and then our spinner here keeps loading forever. And so the problem is that right now we don't have any ID, right? So right here we are trying to read the ID, but then the location doesn't have any hash. And so therefore, maybe you saw it here, we have an empty string, basically. And so then we are trying to find a recipe for the empty string. And so, of course, then we get an error. And that error will then trigger the alert window that we saw. And so let's put a simple guard clause right here, saying that if there is no ID, then return. And that's it. And again, using guard clauses like this is really the modern way of performing this test. So the old way would have been to write if ID, and then we would have to wrap all of this code here into the if block. And so that would then create unnecessary nesting and make our code harder to read. So if we save it now and reload it now, well, then we don't get any error and everything works fine. And so we can now safely click here, and then each of these different links will load these different recipes. All right. And that's actually it for the very core functionality here that we have in our flowchart. So at least of this right side of the flowchart. So this is now basically implemented at this point. However, it is not implemented in a very clean way. And so in the next lecture, it is finally time to talk a little bit about the architecture that we're going to implement in this project. So we already implemented a part of the Forkify application, but at this point, it has no structure whatsoever. And so now it's time to talk about the project's architecture, but also about software architecture more in general. Now, we touched on this already in the Mapty application a little bit earlier, but in this lecture, let's now go a little bit deeper. And first of all, why do we even need an architecture when we build software? Well, there are actually multiple reasons. First, the architecture will give our project the structure in which we can then write the code. So just like a house, software also needs a structure. Now, in software, structure basically means how we organize and divide the code into different modules, classes, and functions. So all these will basically hold our code together and give it structure. The next reason is maintainability. So when we build a project, we always need to think about the future and keep in mind that the project is never really done. It is never finished. We will always need to change things in the future, and we will need to maintain the project. And that only works if the project is nicely structured. Plus, we might even want to add new features to the project, which brings us to expandability. So expandability is basically the ability to easily add new features in the future. And once again, that is only possible with a good structure and a good overall architecture. So the perfect architecture is basically one that allows for all these three aspects of structure, maintainability, and expandability. Now, in order to achieve that perfect architecture, we can of course create our own architecture from scratch. And that's exactly what we did in the Mapd project. However, that only works with a really small project like that one. But when the project grows more complex, then it's going to be very hard to achieve a good architecture completely on our own. And so instead, we can opt for a well-established architecture pattern that developers have been using for years or even for decades. And examples of that are Model View Controller, Model View Presenter, Flux, and many other architectures. And so that is actually what we're going to do in the Forkify project, because it's a bit more complex than the Mapd project. Now, these days, in modern web development, many developers actually use a framework like React, Angular, Vue, or Svelte to take care of the architecture for them. And so in this case, developers don't have to think a lot about architectures on their own. And probably this is actually a good idea at a certain point, especially for large-scale applications. However, and this is key, as I said many times before, it is very important that you really know JavaScript before switching to some of these frameworks. And in my opinion, that includes knowing how to implement an architecture by yourself. And so that's what I will teach you with this project, among many other things, of course. And so this will make it then so much easier for you to learn React or Vue or whatever framework that you choose later down the road. Now, no matter where the architecture comes from and who develops it, there are some components that any architecture must have. And that is business logic, state, an HTTP library, application logic, and presentation logic. So business logic is basically all the code that solves the actual business problem. So that's code that is directly related to what the business does and to what it needs. So if your business is WhatsApp, then your business logic will include sending messages. Now, if your business is a bank, then one of the many parts of business logic will be to store transactions. But if your business is a budget manager, then your business logic will certainly include calculating taxes. So you get the point, right? So essentially, business logic is the logic that is really related to solve the problem that the business set out to solve in the first place. Okay, next is the state, which is one of the most important aspects of any web application. So the application state is essentially what stores all the data about the application that is running in the browser. So the data about the application's front end, basically. So the state should store any data that you might fetch from an API, or data that the user inputs, or what page the user is currently viewing, and so on. And this data should be the so-called single source of truth, which should be kept in sync with the user interface. So that means that if some data changes in the state, then the user interface should reflect that. And the same is true the other way around. So if something changes in the UI, then the state should also change. Now, storing and displaying data and keeping everything in sync is one of the most difficult tasks when building web applications. And that's why there are actually many state management libraries like Redux or MobX. But in this project, we will keep things very simple and use a simple object to store our entire state. Next, the HTTP library is simply responsible for making and receiving AJAX requests. And we have been doing that using the fetch function, And so that's what we will keep doing here. And most real-world applications, of course, need some interaction with the web, and so that's why this is an aspect to keep in mind. Now, about the presentation logic, this is the code that is only concerned about the implementation of the application itself. So it's more the technical aspects of the application which are not directly related to the underlying business problem. So, for example, application logic includes handling of UI events and navigation on the page. That's the reason why this component is many times also called a router. So basically mapping actions to the user's navigation. Finally, the presentation logic, which is also called the UI layer, is of course all about the visible part of the application. So essentially, we can say that the presentation logic is responsible for displaying the application state on the user interface in order to keep everything in sync. All right, now any good architecture has a way of separating all these components. So instead of mixing everything together in one big file and in one big mess. And so let's now take a look at a well-established architecture pattern that we're going to use in this project. And that is the model view controller architecture. So basically, this architecture contains three big parts, which are the model, the view, and the controller. Now, the view is of course for the presentation logic, so it's the part of the application interacting with the user. The model is all about the application's data, and so that's why it usually contains the state and also the business logic that manipulates the state. So these two should be kept closely together. Now, the model is also what contains the HTTP library that might get some data from the web, so like from some API or some backend. And so this is of course also about the data, and so it also goes into the model. Finally, the controller is what contains the application logic, and it kind of sits between the model and the view. So it basically creates a bridge between the model and the view, which in fact should know nothing about each other. So again, the model and the view will exist completely independent from one another, and not even knowing that the other one exists, basically. And in fact, one of the big goals of the MVC pattern, so of this model view controller architecture, is to actually separate business logic from application logic, which makes developing the application so much easier. But as a consequence, we then need something to connect these two parts, and so that is the controller. All right, and now let's actually take a look at a typical flow of actions and of data as soon as some event happens on the user interface, for example, like a click. So to start, it's gonna be the controller who will handle that event, because handling an event is doing something in the application, and that is clearly part of the application logic. Now, this handling might involve updating the user interface and also ask the model for some data. So we can say that the controller dispatches tasks to model and to the view. Or in other words, it controls and orchestrates this entire action, and in fact, the whole application itself. Now, asking the model for some data might of course involve doing an AJAX request to the web. And so that's exactly what the model does. Then when the data arrives, the controller takes the data and sends it to the view. And so finally, to finish, the view will render that data to the user interface and finish this whole cycle. Now, in this diagram, you see two types of arrows, right? So the dotted arrows represent data flow between the different parts, while the solid arrows represent actual function calls and module imports. So analyzing this, we can see that it's only the controller who imports and calls functions from the model and from the view, but never the other way around. And so, as I mentioned before, the model and the view are in fact completely standalone and completely isolated. All right? So again, they don't import each other, and they don't even import the controller. And in fact, they don't even know that the controller exists. All they do is to basically just sit there waiting to get some instructions from the controller. Okay? And this part is pretty important to understand, so take some time to really analyze this. Now, there are actually different ways of implementing the MVC pattern, where some are more complex than others, but this one is my favorite way of doing it, because I think it makes the most sense. But anyway, let's now see this MVC architecture applied to the part of the Forkify application that we already implemented. And so this is a flowchart of loading and rendering a recipe that we already implemented. And then down there's also a reminder of the MVC diagram that we just analyzed. So in this flowchart, handling these events is associated to the controller, right? Then loading the recipe happens in the model. So the controller basically calls some function that is in the model, and then the model asynchronously gets the recipe data from the API. And once that data has arrived, the controller asks for that data, receives it, sends it to the view, which will then ultimately render the recipe on the screen. And that's it. So that's what every step of the flowchart is associated to in the MVC architecture. But this is still quite abstract because remember, the flowchart is simply what we will implement, not how we will do that. And so let's go even deeper and actually take a look at a detailed implementation diagram of our MVC architecture. And again, this is only about loading and rendering a recipe. And let's start by noticing how both the model and the controller are implemented in a module, while the recipe view is actually a class. And we will explore the reasons for this when we actually write the code. But now, once again, let's analyze the same data and actions flow, but this time in this real implementation. So when the user clicks on a search result, there is a control recipes function in the controller, and this is the one that will handle this event. And how exactly that happens doesn't matter for now, so we will come back to this later. What matters is that this controller will instruct the recipe view to render a loading spinner while the user interface waits for the data to arrive. In the meantime, the controller also calls the load recipes function in the model to fetch the recipe data from the Forkify API. Now the model also contains a big state object that we export from the model. And this state will contain all sorts of data, like the current recipe, search results, bookmarks, etc. But anyway, as the data arrives, it will be stored in this state object. And the controller then reaches into the state object, grabs the recipe data, and finally calls the render method on the recipe view with that data. So in order to finally render the recipe to the user interface. So basically the exact same steps as before, but this time actually implemented in our code. Well, at least in theory. And so next up, let's actually go from theory to practice and implement this architecture in our code. Welcome back. So now that you know everything about the model view controller architecture and also how it's going to be implemented in our project, let's now actually go do that in practice. And this is going to be a long lecture, so let's get started. And let's start by creating the necessary new files so that we can then split up our code between them. So let's start by closing all of the folders here. And then inside of stores and JavaScript, let's create a new file, which will be called model.js. And so this is basically going to be the module in which we write our entire model. Then we also need the view, or actually the views, because we will have multiple views, basically one for each feature. So now we're working on displaying the recipe, and so this one is going to be called recipe view. But actually, let's create a new folder here for the views in order not to clutter our JavaScript folder. All right. And so then in here, let's create recipe view.js. So we will have one big module here for all the controllers, then one big file for the entire model. So for all the models, basically. So for the recipe, for search, for bookmarks, and all of that. But for the views, we will have one module for each of the different views. And you'll understand why that makes sense as we keep developing our application. And probably the first reason that comes to mind is that the views are simply much bigger. And so we don't want a file with like 500 lines of code. We could, of course, also split up the model and the controller, and probably many people would do that, but I don't want to have to mess with a lot of files here in this project. That would just make it very confusing for you to follow. So let's actually take a look again here at this architecture that I showed you in the last video. And here we will actually start with the model. So again, we're going to have a big state object, which then inside will contain an object for recipe, search, and bookmarks. And now we will just start with the recipe, and then there will be a function for loading the recipe, right? And so that function will then be called by control recipes, which kind of sits between loading the recipe and then rendering it using the view. So remember that the controller kind of sits between model and the view, so it acts like a bridge. All right, and let's actually keep it open here and close all of these others. And so here in our model, let's simply create that state object. And then in there, we have the recipe, which in turn is also an empty object, at least at the beginning. And then we will export this state so that we can then use it in the controller. And let's put them here just like in the diagram, model, controller, and view. Okay, so we're exporting the state from here. And now let's also create that load recipe function. And of course, we also export it so that we can use it in the controller. So load recipe. And this function will be the one responsible for actually fetching the recipe data from our Forkify API. And so this is going to be an async function. All right. And so now we can actually start grabbing some of the code from here. Okay. So as I said, basically the goal of this lecture is to refactor all the code here into the different parts of the architecture. Okay. So what here exactly is concerned with basically getting the data? So it starts here when we fetch the recipe from the API, and then basically it's all of this here. So all of this. So let's copy it. So rendering the spinner, of course, has nothing to do with the business logic, but really it is only presentation logic. And so this one will eventually go into the view. And then here getting the ID, this is also not business logic. This is actually more about the application logic itself. So about making the application work. And so let's keep that part here. And so again, I will just copy this or actually cut, and put it here. Now we start getting these errors, but never mind. Probably we should actually terminate our process here with Control C so that we don't get errors all the time. Okay, now we need to, of course, adjust this here a little bit. So this first part here makes sense, right? Now we just need to get this ID from anywhere. So right now we have no idea which ID we should actually fetch. And so it's probably a good idea to pass that ID into this function. So the controller is the one that will actually get that ID right here. And so then when it calls the model, so the load recipe function, it can pass that ID into it. Then this part here can all stay the same, and this as well. And this actually should now not be the recipe, but state.recipe. And here we can just create a const from this. And here let's then also log state.recipe. All right. So this function here is not going to return anything. All it will do is to change our state object. So this big state object, which will then contain the recipe, and into which the controller will then grab and take the recipe out of there. And this is going to work because there is a live connection between the exports and the imports. Remember that? So when this state object here is going to get updated by load recipe, then that state is also updated in the controller, which imports the state. So let's now actually import all of that into here. So doing it here at the very top. So import, and then from the model, we simply want to import everything. So we have a couple of named exports here. So again, there are named exports and default exports, and these one are named exports because we explicitly gave them a name. And so here we can simply import everything and then call it the model. And so here in the controller, we will then end up with model.state and model.loadRecipe. Remember that? And then here, the current folder model.js. Okay. So let's go back here to loading the recipe, and the spinner should probably be outside of here. And so here, now let's actually call the function. So let's call model.loadRecipe and then pass in the ID. And this loadRecipe function is an async function. And so therefore, it is going to return a promise. Remember? And so therefore, here we have to await that promise before we can move on in the next step here in the execution of this async function. And so you see, this is exactly the situation of one async function calling another async function that we already studied in one of the previous sections. Remember that? And so again, it is really, really important to keep in mind that an async function will return a promise that we then need to handle whenever we call that async function. At least if we want to get some result out of it, or if we kind of want to stop the execution in the function that is calling the other async function. All right. So again, really important to understand the mechanics of what is happening here. Now here we should probably also have some error handling. So I forgot that part. So try on all the way down here, and then catch the error, and then alert the error as well. All right. So remember that this load recipe function here does not return anything. And so therefore, we are not storing any result into any new variable. Instead, here we will get access to state.recipe. So to that state.recipe that is going to be manipulated right here. So you see that this load recipe function here clearly is not a pure function. So it has the side effect of manipulating this variable that is outside of it. And there would be different ways of avoiding that, but that is just a lot of work, and it's just not worth it here in this case. We are still trying to learn here, remember. But anyway, we now here have access to model.state.recipe. And so just in order to see if everything still works, let's store that recipe into the recipe variable so that we can then render it using this code that we already have here. So just temporarily recipe and then destructure it. So let's give it a save and let's restart our application here. All right. Let's reload here and you see that it's working. Right? So everything we implemented so far was correct. And that's pretty important to keep checking when we are refactoring code like this. Okay. So that was actually the easy part. Now comes the recipe view, which will then contain basically all the rest of the code that we have here. So let's go here and set the view up. So the view is going to be a class, and in this case called recipe view. And we do this because later we will also have a parent class called view, which will contain a couple of methods that all the views should inherit. And so using classes makes all of this very simple to implement. Also, we want each view to have a couple of private methods and properties, and so classes makes this really easy to implement again. And just in general, I feel that classes are really the right way to go here. And again, it will make even more sense once we start to add the parent class of view. But anyway, I mentioned that I want each of these classes to have a couple of private properties. And one of them is going to be the parent element. So parent element, and let's right away set the parent element to the recipe container. So basically to this element, all right? Because this will then make it really easy to render the spinner and to render success or error messages, or to render, of course, the recipe itself. So if each of the views has this parent element property, then it will be really easy to do all of those tasks. And again, that will become really clear once we start adding more and more views. But now the next thing I want to do is to actually export something from this module. So of course, we have to export something from this view so that the controller can then use it. Now, what are we going to export from this view? So we might export, of course, the entire class like this. And so then here in the controller, we would have to import that class and create a new object out of that class. So basically create a new recipe view object, right? However, in that situation, it might be possible to create more than one view, and we would never want that. Also, that would add unnecessary work to the controller, which we basically want to keep as simple as possible. And so in order to avoid all that, we will already create the object here and then export that object. And so like this, no one from the outside of this class here will have access to anything except for the object. So what we will do is to export default and then a new recipe view. All right, and that's actually it. So we don't pass any data in, and so therefore we don't need any constructor even. Okay, and then here all we do is import, and here we then can give it any name. So I'm calling it recipe view because I think that's what makes most sense. And then views, and then recipe view.js. Now, how do we then actually pass any data into the recipe view? Because if we're not creating the new object ourselves, then we cannot pass any data in, like for the constructor, right? So we cannot pass any data into this recipe view, well, because we're creating that object right here in the recipe view module already. But actually, I did that on purpose so that we can create a very nice method called render. So what I will want to do here, and let me already write it here, even before having the method. So what I will want to do is to call recipe view.render. And then here, all we do is to pass in the data, which will be model.state.recipe. And this method here called render is a very common name for methods. For example, in React, it is also called render. And so I think this is a nice name. It's really descriptive of what is going to happen. All right. So if we did export the entire class, then here we would have to do like const recipe view equal new recipe view or something like that. And then here we would have to pass in the data like this when we create the new recipe. And of course, this would also be possible, but honestly, I like it better like this. So having this nice render method is a lot more descriptive and a lot cleaner, and also for the reasons that I explained previously already. Now, anyway, this render method here will now accept this data and will then store it into the object. So let's add the public render method. So this is, of course, part of the public API. So this receives data and will then set this dot data to the data it just received. So we need to declare that up here. And so this render method here and these two properties are something that all the views are going to have in common. And this will be really beautiful to work with, as you will see. But now let's actually do something with this data, which is to actually render it. So basically what we want now is to take all of this code and cut it from here and put it into our view. Okay. Now we will actually not put it into the render method because again, this method will later be common to all the views. So to all the classes. However, each view will of course render a different HTML. And so we will simply have a method that generates that HTML so that the render method can then render that HTML. So if that sounds confusing, let me write it in code. So generate markup. And so this is going to be a private method. And since we're using Babel here, I can already use this syntax here. So pasting the code here. And so this is going to generate this markup variable, and we can actually immediately return that from here. Okay. Now, this is not going to do anything yet, because what is recipe here in this case? It's nothing, right? It's not defined at all. Now, in this case, where is this data actually? Well, it is in this .data, right? So why is that? So let's take a look at our controller. And let's start from the beginning. So the recipe is loaded here, and then that will store it into the state object, right? Here we don't need that anymore. Then here we take model.state.recipe, which is that data that we just received here in step 1. And then that data is passed into the render method, right? And so render method then takes that data and stores it inside of this .data. And so this is so that we can then use that data all over the place inside of this object. And by the way, this is exactly what we have here in this architecture diagram. So inside of control recipes, the load recipe function is called, then the recipe data goes into the state, and then that data passes right through the controller basically and goes into the render method, which then in turn calls generate markup. So you see, we already have many things here implemented already, like data and parent element. We're just missing some small parts, but we are going to get there. But now what we were doing here is to discuss where this recipe data is actually located right now. And we came to the conclusion that it is in this .data. So I will copy it, and then we need to replace all the recipe dot here with that. So I'm hitting Command D. So for you that should be Control D. And then let me paste that dot, and then that's it. All right. Then down here we have this code, which is not supposed to be here, because all this function does is to return an HTML string. And it's going to be the render method that will be responsible for then actually putting that HTML onto the page. Okay. So here, let's say that the markup is this dot, so generate markup. Well, this is probably something that's coming from Babel here. Not really sure why, but apparently VS Code doesn't like this yet. We're still missing the dot here, of course. And now it appears to be working. And of course, we still get some errors here, but never mind about that. We are still refactoring. So we have our markup. Now we need to put it on the page. So again, we need to start by clearing the parent element. And actually, let's create another small method for that. So just to get in the habit of abstracting some code. And so now this is where our parent element will come into play. Because now we can say this dot parent element dot inner HTML and set it to empty, right? And so this method here will be usable for all the views as long as all the views have a parent element property like this one, right? So all of this will become really reusable, as you will see in one of the future lectures. So here we now can then call that. And then to finish, we can finally render that HTML to the page. And so here, once again, we can now use this dot parent element and then insert that HTML there. Okay, so this might already be working, actually. So all of this here looks good to me. Let's take a look at the controller. And you see that this is now a really nice and small function here already, right? Now this one, we actually want to call it control recipes. So let's replace it everywhere. Control recipes. So that's the name that I have here in the diagram. Okay. And so now what we're missing is only to export the render spinner also into the view. So this one, of course, also has nothing to do with the controller, and so it belongs in the view. So of course not a function, but a method. And this one will also be a public method, so that the controller can then call this method here as it starts fetching the data. Okay? And now here again, we have the beauty of the parent element already being inside of the object. So this one we can simply delete, and here we can replace it with this dot parent element. All right. Next up, I'm seeing that this icons variable is not going to be defined anywhere in this module. So we will need to grab that from here. So you see that here we have the icons, and we don't need them here anymore, at least. So now we need them right here. And now what we need to do is to then call this render spinner method right here. So that's going to be recipe view dot render spinner. And here again, we no longer need to pass in the parent element. And just watch how beautiful this is. So we have recipe view and then render spinner. And we already know that this will then automatically render the spinner on the recipe view. And the same is later going to happen with other views. For example, with the bookmarks view. We will also have a render spinner on the bookmarks view, and it's going to work the exact same way. And the same with render. So all we have to do is to call these same methods then on all the views, and they will then simply act on whatever view that we are calling them. Right? And that works so nice because we have this parent element here and also this data property. So I think that this is a really nice architecture. And so let's now actually see if this works. So let's reload this here. And here we have some errors. So apparently if there is a really big error, then Parcel will let us know about that. And in this case, the problem is that it failed to resolve this URL. And that actually makes sense because this view here is in a different folder, right? So here we are only going one folder up, and going up one folder from here will end up in the JavaScript folder. However, we want to go into images. So we need to go up one more level. So like this. Okay, so here we have apparently some bug. Let's just see if anything happens still on this event, and it does. There's still some problem here. Maybe that has to do with the fact that we are using these private methods here. So let me change this here to this one. So right here, yeah. And let's also comment out this one, and then we're not using any private methods anymore. However, that is apparently still not working. All right, so let's take a look here at our this.data. So this.data, just to see what we get here. And so we see that apparently that method is not even being called. And I see the problem. I actually did not call it. So I didn't use the parentheses, right? So what a stupid mistake. So let's roll back on all the changes I did, except of course for this one. But here, probably all I need to do is to call these two methods. Beautiful. So we're back. It's working now again, and it's working really nice, including the spinner. Okay. And so I think with this, we successfully refactored our entire code to this new architecture. Well, not the entire code, actually. We're still missing this handler here and all of this part that is here, but don't worry about that for now. Okay? We will have a separate lecture which will talk about how we can handle events in this particular architecture. For now, what matters is that this works just nicely. There's just one thing that I actually want to change, but that has nothing to do with the architecture.